section is the change of variables in multiple integrals. So the change of variables in multiple integrals. So knowingly or unknowingly, we have used this thing, change of variables, because while dealing with a single integration, we have used this concept of change of variables. So in a single integration, what we have done, we use the method of, or the rule of substitution, or the method of substitution to evaluate the integral. Okay, we use this change of variables as a rule or method of substitution. Method or rule of the substitution. That means if the integral is given a to b f of x dx, where we use the substitution, we put x is u of t, and then what happen? So as x is u of t, so dx is u dash of t dt, and then what about the limits? If x equal to a, so it's getting converted to the integral f of u of t, and this dx is u dash of t dt, where t varies from some c to some d. So under this substitution, what is c and d? So a is u of c and b is u of d. Okay. Similarly, this also can be done by this way: integral c to d f of x and dx by dt. So this is the rule of, or method of substitution in the one variable integration or single integration. So in double integration, our method of converting the rectangular system to a polar system is also a change of variable. So the polar coordinates, use of polar coordinates is a change of variables. So what we do, if the double integral given over some region R, f of xy dA, so where we use the substitution, x is r cos theta, y is r sin theta. So by using this substitution, we get what? X square plus y square is r square, and this small area dA is to be r dr d theta. Okay. So this problem of integration is getting converted to the integral f of r cos theta, comma r sin theta dA, which is r dr d theta. Okay. And what is this region? S, where S is a polar region. Polar region, which is the same region R, which is expressed in terms of a polar region. So S is polar region in R theta plane, and R is a region, plane region in xy plane. Okay. So these were the cases, or the particular cases we have used earlier for this as a change of variables. So generally, how to define a change of variables? So these change of variables are given by those some equations, right? So generally, this change of variables is a transformation or a function. Transformation T from some set S to set R. Transformation T from some set S to some set R. From where this S is polar region in R theta plane or UV plane. From UV plane to a XY plane. Okay, UV plane to a XY plane. Given by T of UV is XY. T of UV is XY. Okay, so where this XY are, where X is related to, where X and Y are related to U and V, U and V by the equations, X is G of U, Y is some H of U. Okay, so T is just a function that is converting the points xy to the point uv or the point uv to the point xy by using these equations. So, and T is what? It is just a function from a uv plane to a xy plane. That means it converts a region S to region R under the transformation or under the map, under the function defined by this way. P of uv is equal to x comma y, where x is represented by this g of uv, y is represented by this h of uv. This is the relation between the variables xy and the variables uv. So if P is a C1 transformation, that means as T is a C1 transformation, it means the components of T will have a continuous first order partial derivative, that is the components x and y, that means g and the function g and h have continuous first order partial derivatives. Continuous first order partial derivatives. And continuous first order partial derivatives. So if this is a UV plane, this is some region S, then under this transformation T, this region S is getting converted to region R under the transformation T. And as T is a function, it is not guaranteed that it is always a one-to-one function. But if it is one-to, if T is one-to-one, in this case we can define a inverse function also. Then transformation P inverse from R to S can also be defined. us see some examples how the region S is getting converted to region R, and how it look like when it is converted from one plane to other plane under the change of variables or under some transformation T. So let us see how the region is converted from one plane to other plane and how it look like. So these are the examples to find the image of a set S under some given transformation T, which is defined by the some equations relation between the variables xy and the variables u v to transform a region from one plane to other plane. Okay. So to transform this region, one thing is that the transformation T is given in each example. So every transformation maps boundary of input region to the boundary of the image region. So transformation T maps boundary of S. What is S? So T is transformation from S into R. So transformation T maps boundary of S into a boundary of its image. Boundary of its image, which is R. Okay. So let's see example 1. Solution to example 1. So the transformation T is given by two equations. X is u square minus v square and y is 2 times u. Okay. And the region S is given with the UV plane. So u axis, v axis 0, and the region S is given by what? U vary from 0 to 1, v vary from 0 to 1. It's 1 comma 0, it is 0 comma 1. So this is the region S, okay, which is a box of size, or sorry, it is a square of size 1. Every side is 1 unit. Okay, so let me name it as side A, side B, side C, side D, and let us see how this square is transformed to the other plane, xy plane. Okay, this square is in UV plane, and how it is getting transformed to the xy plane. Okay, so let us see what happens to these sides A, B, C, D due to this transformation or relation x and y. So for side A, what is it? Side A is how it can be represented. It is v equal to 0, v equal to 0, and u varies from 0 to 1. So side A can be represented by this. So what happens to the x and y? So x is u square minus v square. So it is u square, v is 0, so x is u square, and y is what? V is 0, so y will be 0. It means that when u vary from 0 to 1, so u square will also vary from 0 to 1. Okay, so x will vary from 0 to 1. So this happens for side A. What happens to side B or side B? How we can explain this side B? So it is u equal to 1, and v will vary from 0 to 1. So this is side B. So with these equations, x equal to what? U square minus v square. So it is 1 minus v square. Y is 2 times u, u is 1. So it is 2 times v. Okay. So eliminate this v from those two equations. So what I will do? I will do x equal side B. What happens to side C? Side C is this. What is it? It is the equation V equal to 1, and for this side U varies from 0 to 1. Okay, so what happens to these equations? X is U square minus V square. V is 1, Y is 2 times UV. V is 1, so it is 2 times U. So eliminating U from these two equations, we get X is U square, that means U is Y by 2 square minus 1, that means we get X is Y square by 4 minus 1. Okay, so this is for side C, and the last one for side D. What we get? For this side, the equation of this is U equal to 0, and V will vary from V equal to 0 to V equal to 1. Okay, therefore X is equal to, this will represent U is 0, V square, so it is minus V square, and Y is, as U is 0, Y is 0. So V vary from 0 to 1, so ultimately X will vary from minus 1 to 0. Okay, so combine all these four equations. In xy plane. So what are those equations in xy plane? What are those equations? X vary from 0 to 1. This is 1. X vary from 0 to 1. So this is one thing. X is 1 minus y square by 4. What is the graph of x equal to minus of y square? X equal to minus of y square. So it will be this kind of parabola. Okay. So plus 1. So it will be a parabola of this kind. Okay. And it is shifted to 1. So it will be parabola something like this. Now what will be the point of intersection? So when y is 0, x will be 1. When y is 0, x will be 1, and when x is 0, y square will be 4, that means y has to be plus 2 and minus 2. Okay, so it is 0, 2. So this will be parabola, something like this. This thing, x is y square by 4, how the graph will be? So this is the graph x equal to y square. So the parabola is like something this. So x equal to y square minus somewhere. So the parabola will shifted by distance minus 1. What will be the point of intersections? When x is 0, y will be 1. When x is 0, when y is 0, x will be minus 1. Okay, this is minus 1 comma 0. And when x is 0, y square will be 4. So y will be plus 2 and minus 2. So this will be the parabola. Okay. And this represent x vary from 0 to 1. This represent x vary from minus 1 to 0. And the region enclosed by all these four curves is this region, which is region R. So no need to draw other thing. Okay. So this is the region in UV plane. Under this transformation, x is u square minus v square, y is 2 times uv, is getting transformed to this region under the transformation T. Okay. The next one, number 2. Number 2, solution. is it? The transformation T is given by x equal to 2u plus 3v and y is u minus v. And the region S is what? Region S in UV plane is u varying from 0 to 3 and v varying from 0 to 2. Okay. So it is a rectangle. Sorry, in UV plane, u vary from 0 to 3 and v vary from 0 to 2. So this is region S. Okay, in UV plane. So let me name it as A, side B, side C and side D. And let us see what happens to this sides of this rectangle under this transformation T. Okay, so for side A, what is this equation of side A? It is u equal to 0 and v vary from, it is v equal to 0 and u vary from 0 to 3. So this is equation of side A. So what happens to the x and y? X is 2 times u plus 3 times v. V is 0, so it is x is 2u, y is u minus v is 0. Eliminate this variable u or v. So u is here, so we are getting x is equal to 2 times y. So I am getting this thing. No need to write the limits because intersection of all these sides will ultimately give us the area or a region in xy plane. Okay. For side B, what is it? This line. So its equation is u equal to 3 and v vary from 0 to 2. 0 to 2. Okay, this. So let us see, x is, for this, u is 3. So 2 times u is 6 plus 3 times v. And what is y? U is 3 minus v. Eliminate the variable v from these two equations. So what we get? X is 6 plus 3 times and v can be written as, from this, 3 minus y. So it is x is 9 plus 6, 15 minus 3y, or x plus 3y equal to 15. Okay. Next, for side C, this side C, this, the equation is v equal to 2. V equal to 2, and for this side u varies from 0 to 3. Okay. So what happens to the equations? X is 2 times u plus 3 times v, so it is 6. Y is u minus v, v is 2. So eliminate u from these two equations. X is 2 times u, u is y plus 2 plus 6. So what we get? X is 2y plus 4 plus 6. So it is 10 plus 2y. That means what we get? X minus 2y is 10. So these are the equations we are getting. And for next, side B, what is it? This is v axis. So its equation is u equal to 0, and for this side v varies from 0 to 2. Okay. So x is 2 times u, which is 0. So x is 3 times v, and y is u minus v. U is 0, so it is minus v. Eliminate v. So it is x equal to 3 times v is minus y. Okay. So what we get? X is minus 3y. Okay. So try to draw all these 4 lines in xy plane. Okay, I will draw. I need a larger space. So this is x-axis, y-axis, origin. Okay. So what is the line x equal to 2, 1? The line y equal to x is this. Y equal to x by 2 is this. So it is x equal to 2, 1. Okay. Then the line x plus 3y equal to 15. So if x is 0, y is 5. If x is 0, y is 5. So it is 0, 5. And when y is 0, x is 15. So it is not in proportion. So let me call it as 0, 5. This x-axis, let me call it as 15, 0. When y is 0, x is 15. So this is the line. Okay. Then the next thing, x minus 2y equal to 10. When y is 0, x is 10. When y is 0, x is 10. Okay. And when x is 0, y is minus 5. When x is 0, y is minus 5. And then x equal to minus 3y. So y equal to minus x is this. Y equal to minus x by 2 will be this. So it is this. X equal to minus 3y. So what is the region that is bounded by these 4 lines? So this is the region. It is region R. Now find out the point of intersections for the 2 into equations. Okay. So this is x plus 2y. This is what? X plus 3y equal to 15. This is x minus 2y equal to 10. Okay. So the point of intersection of these two, x is minus 3y. Minus 2y is 10. So minus 5y is 10. So y is 2. Y is 2. So x is 6. So this is 6 comma minus 2. Okay. What about the point of intersection of these two lines? X plus 3y equal to 15. So 2y plus 3y is 15. So 5y equal to 15. So y is 3. Y is 3. So x is 6. It is 6 comma 3. What about this? Intersection of two lines. X plus 3y is 15 and x minus 2y is 10. So taking subtraction, what we get? 5y is 5. So y equal to 1 and y equal to 1 implies x equal to 12. So for this example 2, the region which is getting converted here is a region with or a parallelogram with the points or the corners 0, 0 origin, 6, 3, 12, 1 and 6, minus 2. Okay. The next example number 3. is region bounded by the lines. S is a unit square. What is it? This thing. Okay. U, V, origin, and this is a unit square. 1, 0, 0, 1. This is region S. Okay. So let me call it as sides A, B, C, D. So for side B, what happens? What is it? It is V equal to 0, U vary from 0 to 1. Okay. So X is what? 0, Y is U times 1 plus 0. So is U. So Y will vary from 0. X is 0. And Y vary from 0 to 1. Well, I have eliminated U. So for side B, what the equation is U equal to 1 and V vary from 0 to 1. Okay, so the equation represents X is V and Y is U times U is 1 times 1 plus V square. So eliminate V. So it is easy to write Y equal to 1 plus V square means 1 plus X square. Okay. Then the next side for side C, it is the equation V equal to 1 and U will vary from 0 to 1. So X is V, that means 1, and Y is U times 1 plus V square, that means 1 plus 1. So X is 1 and Y is 2 times U. So it is X equal to 1. As U vary from 0 to 1, Y will vary from 0 to 2. Okay. And the last side D is what? This U equal to 0 and V vary from 0 to 1. That is, the equation represents V is X is V and Y is U times U is 0. So Y is 0. So it is what? Y equal to 0 and X vary from 0 to 1 as V vary from 0 to 1. So this is X axis, Y axis, origin, and how the side A is transformed. Side A is X equal to 0, that means Y axis, and Y vary from 0 to 1. Okay, Y vary from 0 to 1. So this is the image of side A. This is image of side A. Okay. Next, side B is getting converted to Y equal to 1 plus X square. So generally the graph of Y equal to X square is this. Y equal to 1 plus X square, so graph is shifted by 1 time. So Y equal to 1 plus X square is this graph. Y equal to 1 plus X square. The next thing, X equal to 1. X equal to 1 and Y vary from 0 to 2. This is 1, 0. X equal to 1 and Y vary from, this is Y equal to 1 plus X square. The point of intersection of these two things is 1, 2. Okay, so this is image of B, this is image of side C, which is X equal to 1, Y vary from 0 to 2, and Y equal to 0, X vary from 0 to 1. It is image of side B. Okay, so the region of integration is this, which is enclosed by the images of all the 4 sides in the XY plane. Okay, so the next one you can take it as an exercise for you.